All right, today and tomorrow we're going to be covering balancing equations. So, recently, yesterday, we learned about the five types of chemical reactions, which are synthesis, decomposition, single replacement, double replacement, and combustion. Today, we're going to learn how we keep those equations in balance and why we even bother to keep them balanced. So our objective is that we'll be able to count atoms in chemical reactions and balance them as per the law of conservation of mass. Okay? So first of all, what even are chemical reactions? We remember what chemical reactions are because we just learned about them. But there's something that applies to all chemical reactions called the law of conservation of mass. And what that is that chemical reactions must be balanced, which means that the number of atoms on the reactant side and the product side must be equal. If I have 4 atoms of oxygen on the reactant side, I also have to have 4 atoms of oxygen on the product side. But how do I count how many atoms are in each or are on each side? First thing I have to recognize is that we use something called subscripts. We've talked about subscripts a lot. You've already seen them. They are the small numbers that are in subscript behind your element symbols, your chemical symbols. Subscripts apply to the element directly before it. So in this example, phosphorus's or P, phosphorus's subscript is 6 and chlorine's subscript is 3. Okay? So that means that I have 3 atoms of chlorine, but I don't have 3 atoms of phosphorus. I have 6 atoms of phosphorus in this example. And that's only half right. We'll talk about why later on. So somebody go ahead and help me out with this. If subscripts only apply to the element immediately before it, how much magnesium do I have? And how much chlorine do I have? Okay, that's exactly right. So I have 2 chlorine atoms and I have 1 magnesium atom. Why do I only have 1? Yes, because there's no subscript behind magnesium. That's why. And if there's no subscript, then we can assume that the number is 1. The next thing we're going to talk about is coefficients. And coefficients are in front of a compound and they multiply the entire molecule, the whole compound. So in this example, we are still working with phosphorus chloride. Okay, we're still working with that guy. We still have 3 atoms of chlorine, and we still have 6 atoms of phosphorus. However, we have a coefficient which applies to the whole molecule. So this is like the distributive property that you learn in math. You're going to take this 3 and you're going to multiply each of these individual numbers by that number. So I'm going to do 3 times 6, which gives me 18, and 3 times 3, which gives me 9. So that means that instead of 6 phosphorus atoms, I have 18, and instead of 3 chlorine atoms, I have 9. Okay, so let's try with the carbon hydroxide, which is down here at the bottom. How much carbon do I have, and how much hydrogen do I have? Perfect. Perfect. So 2 times 6 means 12 carbon atoms, and 2 times 2 means 4 hydrogen atoms. So the first part in understanding how we keep balance in our chemical equations is understanding how we count up the atoms. And we're pretty much there. But one more thing. If there are parentheses, then the subscript multiplies everything inside of the parentheses. Okay? So in this example, I have a 2 outside of the parentheses. Again, we're going to distribute. I'm going to take this 2. I'm going to multiply it by 3. And then I'm going to multiply it by the 1 that we can't see for nitrogen. Okay? So that means that I have 6 oxygen and 2 nitrogen. And then we take that subscript and we do the same thing. 3 beryllium atoms. And then that 3 is also going to spread into our parentheses. You're going to do 2 times 3, which is 6, and 6 times 3, which is 18. And that's our answer for the numbers down at the bottom. Okay? I just want you guys to take a few moments to practice how many counting up atoms in each element. So how many atoms of each element are in these equations? Don't forget to use your subscripts. I'm going to go ahead and give you guys about 3 minutes to do that. Your time starts now. Okay, great. So that's our 3 minutes. Now we're going to go ahead and discuss the answers that we got. All right, so you guys did a great job on counting up atoms. Now we're going to talk about how we balance equations now that we know how to count atoms on each side. So first, we have to understand what we're looking at when we look at an equation. We know that the reactants are on the left. We know that the products are on the right. We need to figure out how we decide if an equation is balanced. And to do that, you just compare the number of atoms of each element that appear on each side of the equation. If the number of atoms is equal, then the equation is balanced. If it's not equal, then the equation is not balanced, okay? So looking at this here, I have carbon hydroxide and oxygen. I have 3 atoms of carbon and 8 atoms of hydrogen, and I have 10 atoms of oxygen, because remember, we have to do the math on that coefficient right there and the subscript, okay? On the other side of this, I have a subscript and a coefficient on both sides. I have a 3 in front of the carbon, so that 3 is going to apply to the carbon. So that means I have 3 carbon on both the right and the left side. Perfect. Now I'm going to check hydrogen because hydrogen's next. I have a subscript of 2 and a coefficient of 4. So I'm going to multiply the 4 and the 2. I'm going to get 8. That's perfect because I have 8 hydrogen on my reactant side, aka my left side. Now I have to make sure that I have enough oxygen. On the left side, I have 10 oxygen. On the right side, my oxygen is in 2 places. So I'm going to do the math on the first oxygen. That's 3 times 2, which gives me 6, which does not equal 10. But the oxygen back here in the final portion has a 4. And we know 6 plus 4 equals 10. So that means that this equation is in fact balanced. And that's all you're doing. That's all you're doing when you are figuring out how to balance equations. You're just making sure that you have the same amount on each side. Okay? So the steps for balancing equations, there are 4. Count the atoms of each element on each side. Add the coefficients to start balancing. Never change the subscripts. You can change coefficients, but you cannot change the subscripts. And then you have to do the math all over again each time you change a coefficient. And then you're just going to check your work. Okay? So what does that look like? You'll see an equation and it doesn't have anything in it, right? It's just bare, it's basic, it's empty. Okay. So the first thing that we need to do is figure out which side of the equation we want to tackle first. Personally, I find it easier to work with the side that has compounds. Okay, when we're dealing with one side that has compounds and one side that doesn't. So in this example, I have nitrogen, I have hydrogen, then I have nitrogen hydroxide. This is actually a covalent bond, so it would be nitrogen trihydroxide because we're remembering our prefixes. Okay, so 3 does not match any of these. I have 3 hydrogen, I have 1 nitrogen. The easiest thing for me to do is figure out the common numerator between 2 and 3. That's going to be 6. Okay? 2 and 3 share 6 in common. If I multiply 2 by 2, I get 4. If I multiply 3 by 2, I get 6. So if I multiply 2 by 3, I also get 6. So I want to try to get this hydrogen up to 6. And the easiest way to do that is for me to multiply this whole side by 2. Okay? So 2 times 3 now makes this 6. But I also have to remember that what I do to one part of this compound, I also do to the other part. So 2 times n, or 2 times that 1, equals 2. So what I did to one side, I also have to do to the other. If I made 6 hydrogen on the right side, I also have to make 6 hydrogen appear on the left-hand side, and I need to make 2 nitrogen appear over there too. Okay, so first things first, how do I make that 6 hydrogen appear? Well, I just multiply by 3 because 3 times 2 gives me 6, which means now I have 6 hydrogen here and 6 hydrogen here. And on this side, our final product, because I already had a subscript of 2 over here, I didn't actually have to put a coefficient in front of nitrogen on the left-hand side, the reactant side. All I had to do was leave that 2 in front of the product side. So now I have 2 nitrogen over here, and 2 nitrogen over here, and 6 hydrogen here, and 6 hydrogen here. And that is the goal. Let's try it again. So here I have a decomposition reaction. I have iron oxide. I have 1 atom of iron over here and 2 atoms of oxygen. Again, I tend to find it easier to just work with the part that's already a compound. All I need to do is get this oxygen atom up to match this one. Okay? And to do that, I know that there are invisible ones here. I'm going to place a what number in the front? Correct, a 2. I'm going to place a 2 in the front of this problem. Remember, because this is a coefficient, that I have to distribute the 2 to iron and oxygen. So now my oxygen on the left-hand side matches my oxygen on the right-hand side, but iron on the right-hand side, the product side, it's out of whack. So what do I have to place here to match up this side with this side? Perfect. You're just going to place another 2 there. And now you're done. You have 2 iron atoms on both sides and 2 oxygen atoms on both sides. Before I release you guys to do some independent practice, your homework, I want to give you a few helpful hints. The first is that you start with the atoms that appear only once on each side. So if it's a double replacement reaction and you have hydrogen twice on the right-hand side, don't start with hydrogen. When you have an even number on one side and an odd number on the other side, it is helpful to change the odd number into an even number first. So it's helpful to multiply until you have an odd number and an even number. An even number on both sides, because it's always easier to multiply your even numbers than it is to multiply your odd numbers. And then last but not least, if you have a polyatomic ion and it appears on both sides of the equation, keep it together. Do not separate it, because polyatomic ions are not meant to be separated. Okay? So we're going to go ahead and we're going to practice. It's the homework. And we'll review your homework answers tomorrow as our warm-up. I'll see you guys later.